Okay, this lesson is a lesson on how to draw vector diagrams. Okay, a lot of students have problem drawing vector diagrams to find the resultant force. So this video is for you. So before I start, I would like to point out two important points. The first thing is that there are actually two methods to solve for the resultant force, but I'll prefer to use the tip to tail method as compared to the parallelogram method. The reason being is that the tip to tail method is a more superior method as compared to the parallelogram, but in this lesson I will not be elaborating on why. Okay, in a future lesson I might explain myself further. Okay, another thing is that I would prefer students to keep the orientation of the forces when they are drawing the vector diagrams. Why is it so? And what do I mean by the orientation? What I meant is that if the force points is in the question, okay, please do not draw it to the north. Okay, actually some teachers might say that it's okay so long as your resultant force is correct. But my concern is that after you have drawn the question, the answer, and then when you try to describe the direction of the resultant force, you might explain it in the wrong direction. Okay, so this is one common mistake that students make. So try to keep the orientation. So what I meant by that is to make sure that if it points to the east, okay, draw it to the east. If it points to the north, draw it point to the north. Don't change the direction. Okay, so let's move on. So the content, we're going to touch on three things. First is we're going to ask ourselves what exactly is a resultant force. Secondly, we're going to talk about what is a tip to tail method. And lastly, we're going to find the resultant force and we're going to describe the direction. Okay, so let's dive into the first one. What is resultant force? Okay, this is how I'll define resultant force. It is a single force that can represent the overall effect when many forces act on an object. Okay, so in this case, let's say we have a very simple case where the forces are parallel to each other. So if there is a 10 and a 4 Newton force acting on it, the effect is that this body will definitely move to the right because the 10 Newton is more stronger than the 4 Newton. Alright, but this effect of accelerating to the right is similar to assuming that you have a single resultant force of 6 Newton to the right. They have the same effect on the body. Okay, let's consider a case where there is many more force. Okay, even if there are many forces acting on the body, again you can use one single force to represent it. Okay, in this case you can say that it is a total of 40 newtons to the right. Okay, they can represent the whole thing. Okay, so that means that in both cases just one single force is able to represent everything that is acting on the body. Now the question is, when students see a question that the forces are no longer parallel to each other, they don't relay it back to the previous cases that they understand. Now, so what this means is that actually when you see forces that are not parallel to each other, when they add up, they also have one single force that can represent them. But you must know that it is not a simple case of 5 plus 5, okay, because there is some direction involved. Okay, so what I meant is that in this case, this body here will be acted on by two forces that are not parallel to each other, and eventually you can also use one single force to represent the effect of these two forces. Okay, so first of all, let us talk about what is tip to tail. Okay, let's just define the tail and the tip of a force. The tail of the force is the end of the force, or the starting point of the force, not exactly the end, the starting point of the force. And the tip is actually the head of the force. Okay, the head of the force. So you need to bear in mind the tip and the tail location. So when you draw the forces in your graph, okay, in your paper, you should have it in this way. Okay, why do I say in this way? Okay, look at the point where the two forces meet. Okay, this point. Alright, the first force tip is pointing to the second force tail. So this is what I call tip to tail. That means that one tip and one tail is in contact with each other. Okay, let's look at examples that are not tip to tail. Okay, this is one example. Okay, if you look at the point where the two forces are in contact, it is a tail and another tail. So this is a tail to tail, which is not tip to tail. And another case is this, where it is a tip to tip. Alright, so actually we are very concerned about students who draw the wrong graph. Okay, they need to know that the graph that we want is the first one. Okay, this is the correct one, and these two are the wrong one. Okay, so please do not produce graph that has tail to tail or tip to tip. Okay, always after you have drawn it, look at the point where the two forces join and ask yourself whether they are tip to tail or not. Okay, let's move on. Now, how do you find the resultant force of, let's say, this case? All right, how do you find it? Okay, so let me just go back to the pointer. Now, the first thing is that, okay, sorry, I cannot use the pointer. I have to exit first and use this. Okay, so what happened is that the first case is that you need to keep the orientation of the force. For example, if you take this 5 Newton force out, alright, the second force that you're going to draw is not the same location as the first force, but to draw it like that. Okay, that means that touching from the beginning of the ending of the first force. That means the first force you put it this way, and then you just align the tail of the second force to the tip of the first force. So the resultant force is simply, alright, here. Okay, the resultant force is simply here. Okay, this will be the resultant force. It starts from the tail of the first force and ends at the tip of the second force. Alright, that's how you draw the tip to tail. Okay, let us do some practice now. So let's look at question number 1. If you have two forces that are acting perpendicular to each other, how will you draw the tip to tail? So first of all, you select one of the force. Let's say I select the 4 Newton force. Okay, you draw it on your graph and then on your paper, and then after that you must remember that the second force will come onto the first force. Okay, let me just go back to pointer. Okay, the second force, the tail. Alright, where's my pointer? Okay, the tail will come to the first force. So what happened is that their tip and tail meets. Okay, so if you, after you have aligned it correctly, tip to tail, the resultant force will be from the first force tail to the second force tip. So this will be your resultant force. Okay, let's move on. Okay, second question. You may want to pause the video for a while and try yourself. Okay, you may pause now. Okay, so have you done it? If you have done it, let's review the answer. So once again, I take one of the forces. Okay, in this case, if you have problem drawing the direction to keep the orientation of the force, remember you can always draw a reference line. Okay, the reference line in this case is the horizontal line. Okay, after you draw the reference line, then you draw the angle and then you draw the force, and you will keep the direction correctly. Okay, then secondly, of course, this second force, the tail will meet the tip of the first force, and then you get tip to tail, tip to tail. Alright, so the resultant force will start from here and end here. So this is your resultant force. Okay, so the question, once again, you may pause the video and try yourself. Okay, so have you finish. Okay, let's review. Okay, the first force is this one, then the second force is this one, and then this will be our resultant force. Okay, so I hope that at this point in time you will be able to do your tip to tail. Okay, I'm going to move on to finding the magnitude and direction. Okay, so imagine if you use question number 1, okay, and you draw a scale diagram, okay, and then you manage to read the scale. I'm not going to touch on how to read the scale in this case. Okay, obviously the magnitude is going to be the value of the resultant force, which is 5 Newton. There's nothing special about this. But the problem is a lot of students do not know how to define the direction. Okay, what the easiest way to define the direction is to reference the resultant force with respect to a force that is next to the resultant force. Okay, in this case the force is the 4 Newton force. Okay, they are next to each other. So what is the angle between them? The angle between them is 36.9 degrees. So what is the direction between them? Okay, the direction is this. If you are the 4 Newton force, how much do you need to change your direction so that you become a 5 Newton force direction? So your 4 Newton force will have to move all the way to here in this rotation. That means you have to rotate. It's 4 Newton from here to here. So this directional rotation is clockwise or anti-clockwise? Anti-clockwise, alright, because clockwise will be like that, and anti-clockwise will be like that. So obviously this is an anti-clockwise rotation from the 4 Newton force, so the direction will be 36.9 degrees anti-clockwise from 4 Newton. Okay, and this will be how you define the direction. Now I'd like you to try this question now. Okay, you may pause the video and try it. Okay, have you done? So obviously the magnitude will be 529 Newton. Again, how to read the scale diagram, how to interpret scale, we will not be touching because it's very difficult to explain in slides. But what I want to talk about is the direction. Again, the adjacent force to the 529 resultant force will be this 200 Newton. Okay, and the angle between them will have to be the sum of these two angles. Alright, so obviously is 40.9 degrees. Okay, so how do you write? Now for the 200 Newton to reach the 400 Newton, it has to rotate anti-clockwise. So it is 40.9 degrees anti-clockwise from 200 Newton. So that's how you explain. Okay, so I hope this comes to the end of my lesson on the vector diagram. I hope that this has enlightened you a bit on how to find the resultant force. And if you still have any queries, you can write any comments and then I will try to answer them as well. Okay, thank you and have a nice day.